Bonding bushing is not needed when using an offset nipple if one end is threaded into a Myers hub. The requirement for bonding bushing arises only when both ends of the nipple are threaded into non-metallic conduit bodies. This is because the purpose of a bonding bushing is to provide a reliable grounding path when using metal conduit or enclosures. The Myers hub, being a metallic fitting that is properly grounded, provides a sufficient grounding path when directly connected to the offset nipple. When both ends of a nipple are connected to non-metallic enclosures or conduit bodies, the bonding bushing is necessary to ensure electrical continuity and a low impedance path to ground. This is crucial for safety, allowing fault currents to flow back to the source, tripping the overcurrent protection device such as a circuit breaker or fuse. Understanding the specific applications where bonding bushings are required is essential for compliant and safe electrical installations. Not using a bonding bushing where required can lead to hazardous conditions, including electrical shock and fire. Electrical codes, such as the National Electrical Code, or NEC, detail these requirements to ensure electrical systems are installed in a manner that minimizes risk. The NEC Section 250.92 covers bonding requirements for equipment grounding conductors. It specifies the methods for ensuring electrical continuity of metal raceways and enclosures. This includes the use of bonding bushings, bonding jumpers, and other approved methods. The key is to provide a continuous, low-impedance ground fault current path. Now consider an example where a metal conduit enters a non-metallic enclosure. In this case, a bonding bushing is required to bond the metal conduit to the equipment grounding system. The bonding bushing is typically connected to a grounding conductor, which is then connected to the grounding electrode system. This ensures that any fault current flowing through the metal conduit will have a path back to the source, tripping the overcurrent protection device. In contrast, if the metal conduit enters a metallic enclosure that is already properly grounded, a bonding bushing may not be required. This is because the metallic enclosure provides a sufficient grounding path. However, it is important to verify that the metallic enclosure is indeed properly grounded and that the connection between the conduit and the enclosure is secure. The size of the grounding conductor connected to the bonding bushing is determined by NEC Table 250.122, which is based on the size of the overcurrent protection device protecting the circuit. The larger the overcurrent protection device, the larger the grounding conductor required. This is to ensure that the grounding conductor can safely carry the fault current back to the source. It is also important to consider the type of metal used for the conduit and enclosures. Different metals have different conductivity properties which can affect the effectiveness of the grounding path. For example, aluminum conduit has a higher resistance than copper conduit, so a larger grounding conductor may be required when using aluminum conduit. When installing bonding bushings, it is important to follow the manufacturer's instructions. The bonding bushing should be properly tightened to ensure a good electrical connection. The grounding conductor should also be properly connected to the bonding bushing and to the grounding electrode system. It is also important to inspect the bonding bushing and grounding conductor regularly to ensure that they are in good condition. Corrosion, damage, or loose connections can compromise the effectiveness of the grounding system. In addition to bonding bushings, there are other methods for ensuring electrical continuity of metal raceways and enclosures. These include bonding jumpers, which are used to connect two separate pieces of metal together, and grounding lock nuts, which are used to secure conduit to enclosures. The choice of method depends on the specific application and the requirements of the electrical code. Regardless of the method used, the goal is always the same: to provide a continuous, low-impedance ground fault current path. This is essential for protecting people and equipment from electrical shock and fire. In the case of the offset nipple and Myers hub, the direct threaded connection into the Myers hub typically provides sufficient electrical continuity, assuming the hub itself is properly bonded to the grounding system. The NEC also addresses the use of listed fittings. If the offset nipple and Myers hub combination is listed for grounding purposes, this provides additional assurance of their suitability for maintaining electrical continuity. It's crucial to check the product listings and manufacturer's specifications to verify this. Always consult the latest edition of the NEC and local electrical codes for specific requirements in the area. Electrical codes can vary by jurisdiction, and it is important to comply with all applicable regulations. When in doubt, consult with a qualified electrical inspector or engineer. They can provide guidance on the proper installation and grounding of electrical equipment. They can also help identify potential hazards and ensure that the electrical system is safe and compliant. The proper grounding and bonding of electrical systems is essential for safety. By understanding the requirements of the electrical code and following best practices, electricians can ensure that electrical systems are installed in a manner that minimizes risk. This includes selecting the appropriate grounding and bonding methods, using the correct size grounding conductors, and properly installing and inspecting grounding and bonding equipment. Remember that electrical work can be dangerous, and it is important to take all necessary precautions. Always to energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and safety glasses. If you're not qualified to perform electrical work, hire a licensed electrician. Electricity is a powerful force, and it should be treated with respect. Grounding and bonding are not just about meeting code requirements, they are about protecting lives and property. By understanding the principles of grounding and bonding and following best practices can help ensure that electrical systems are safe and reliable. The NEC also provides guidance on the proper selection and installation of grounding electrodes. Grounding electrodes are used to connect the grounding system to the earth. This provides a path for fault current to flow back to the source, stripping the overcurrent protection device. There are several types of grounding electrodes, including ground rods, ground plates, and metal underground water pipes. The NEC specifies the requirements for each type of grounding electrode. The NEC also addresses the use of supplementary grounding electrodes. Supplementary grounding electrodes are used to improve the effectiveness of the grounding system. They are typically used in areas with high soil resistivity or where the grounding electrode system is not performing adequately. The size and number of supplementary grounding electrodes required depends on the specific conditions. The NEC also provides guidance on the proper installation of grounding electrode conductors. Grounding electrode conductors are used to connect the grounding electrode to the equipment grounding system. The NEC specifies the size and type of grounding electrode conductor required, based on the size of the service entrance conductors. The NEC also addresses the protection of grounding electrode conductors. Grounding electrode conductors should be protected from physical damage and corrosion. They should also be installed in a manner that minimizes the risk of accidental disconnection. The NEC also provides guidance on the inspection and testing of grounding systems. Grounding systems should be inspected and tested regularly to ensure that they are performing adequately. The NEC specifies the methods for testing grounding systems, including the use of a ground resistance meter. A ground resistance meter is used to measure the resistance of the grounding system to earth. A low resistance indicates a good grounding system, while a high resistance indicates a problem with the grounding system. If the ground resistance is too high, the grounding system should be repaired or replaced. The NEC also addresses the documentation of grounding systems. Grounding systems should be documented, including the location of grounding electrodes, the size and type of grounding conductors, and the results of grounding system tests. This documentation should be kept on file for future reference. The proper grounding and bonding of electrical systems is a complex topic, but it is essential for safety. By understanding the requirements of the electrical code and following best practices, electricians can ensure that electrical systems are installed in a manner that minimizes risk. This includes selecting the appropriate grounding and bonding methods, using the correct size grounding conductors, properly installing and inspecting grounding and bonding equipment, and documenting the grounding system. Remember that electrical work can be dangerous, and it is important to take all necessary precautions. Always to energize circuits before working on them, and use appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Electricity is a powerful force, and it should be treated with respect. Grounding and bonding are not just about meeting code requirements, they are about protecting lives and property.